I became interested in coastal ecology research because I grew up in a fairly rural place that was real beautiful and had lots of nature, and as a kid I really loved that. And later, about the time I was 12, I moved into a fairly heavily industrialized area with a lot of chemical plants and things like that, and so the juxtaposition of the early life and the later childhood, the teen years, kind of really put environmental issues to the forefront and in my mind, and they were coastal places, so naturally I just liked the coast, and playing in the water on the coast and doing different things there and growing up around it. And so that was the system I was immersed in, and that juxtaposition kind of made me into environmental mindset, and so that's what I went in to study. I use maybe three kind of different strategies or approaches to do research, with individual tools maybe inside each of those approaches. So I do things in the field about a third of the time, or the third of my emphasis, and so there we use like water monitoring gauges or salinity gauges. We use things to measure wind. We measure rainfall. We measure plants and biomass and soil features and organic matter features, and so really measure water, soil, and just the environment and the biological plants mostly, but sometimes animals in those environments, and a lot of different methods to do that. So that's about a third. And the other third, we actually come back and sit usually at the computer, and we use spatial tools, so GIS or Geographic Information Systems, remote sensing products, so like satellite images or aerial photography. And so we're kind of looking at a bigger place than we can conceivably walk across. So the things in the field, maybe we have a few point samples, or as many samples as we can get, but we can only do so many places. And then when we do it in the lab, in the computer lab, we can kind of extrapolate between those using imagery or a bigger scaled approach. So we can look at huge landscapes, so maybe several miles of area or even bigger. So linking those two features gives each more power. And then the third part, about another third of what I do with my time, is maybe kind of other, but I guess I would say it's more lab-based, non-computer lab. So we'll use wave tanks, or like basically big fish tanks where we have water going through it and making waves or flow in there, and we're looking at how plants can change erosion or respond to waves or alter soils and things like that. Or maybe we're just doing some random lab thing, like doing something funny to soils, like cooking them or doing this or grinding them and measuring certain attributes of soils or plants or things like that. So that kind of links a lot, with the other. We tend to look at the mechanisms of change with those types of techniques. So when we can't do something in the field because the field is too noisy or too messy or too uncontrollable, and the imagery is too coarse or too big of an area to look at, when we are looking at specific physical mechanisms of where like a wave is hitting a plant and how the plant architecture changes the wave form or things like that, those kinds of things, or we'll do that in a laboratory context. So those three aspects kind of go together in my research. I think maybe two things. One is looking at erosion and accretion, which is building land, but mostly eroding land, and how plants or ecosystems can alter that and potentially reduce it, or in different ways they do that. In some cases they can reduce erosion, in other cases they can't, and the different nuances between different plant types or parts of plants or different physical forms of force like waves or flow. Those are very wide open questions. I think most people look at it really simply. in two diametrically opposed views of like engineers that are like, we have to armor the coast and ecosystems can't do much of anything to help us, and versus ecologists, which will say that ecosystems do everything we want them to do and they can protect us from all the bad things in the world. So I think I try to look at the interface between those two things and take the tools from both. But doing that work in a wider context of how humans interact with those natural processes. So the natural processes of the biology of the plants and the physical forces of, say, waves, and the sediments and how those things are all interacting in erosion. But the wider context is how humans play into that, and how do human decisions change that, or humans want things to be stabilized versus the world needs to be dynamic. And that research I like in the basic sense, but also looking at it in a broader sense of how this affects future management of the world by humans, and how we need to manage land, and look at maybe New York after Hurricane Sandy. How can we make it more resilient? And where should we have engineering projects or walls or seawalls or bulkheads, and where should we be using plants to help reduce erosion? Questions like that. So that's a big part of research that's exciting, not only in the basic side because it's really hot research and you can publish it in really high places and very important types of research that is very unknown and very wide open now, but also because there's that huge management aspect that really affects a lot of people and that are impacted by hurricanes and sea level rise all the time, and in most of the world, most of the people in the world, in fact, live in that type of zone. And then the other thing that I'm really interested in, the other aspect of research, is kind of applied, but in restoration. I think there's a lot of the world of restoration, and the need to restore coast is becoming bigger and bigger, and it's kind of a cool testing ground to test out a lot of ecological concepts, because we're kind of rebuilding ecosystems, and so we are seeing, is the things we think that make them work really working? Because when we try to build it, we find that out, if we're doing it right or wrong. And so restoring wetlands or restoring beaches or dunes is kind of exciting, and it's exciting a lot of times too because there's a lot of players involved, like private property owners or county or state officials or federal agencies, and lots of laws and money and politics and the science involved as well. So all those things go together to make a project possible, and it's in the real world, and you're really changing an ecosystem and potentially increasing the fish or increasing the birds or making the people that use that landscape happier by protecting their land or increasing the fish that they fish. And so we're doing some work like that, and I think that'll only become a bigger deal because there's a lot of money being thrown at that in the last few years as a result of the BP oil spill, and just everybody in general wants to start thinking about protecting and restoring ecosystems. So that's another area.